Suppose we have a Cobb Douglas production function, normally written y equals f of kl, and with the Cobb Douglas production function we'll give some specific form to that production function and have it be k to the alpha 1 l to the 1 minus alpha, where alpha is a number between 0 and 1. So this is a production function that if you can plug it into Excel, you can go into Excel and suppose that you have alpha equal 0.1, 0.2, 0.3, 0.4, and then 1 minus alpha would be 0.9, 0.8, 0.7, 0.6, and then you can have different levels of capital and different levels of labor. So you can suppose capital was 10 and labor was 30. And then your final column would be output, which would be equal to 10 to the 0.1 times 30 to the 0.9, and that would give you some numbers. So you can load that all into Excel to get an idea of how the production function actually works. Now, going back to our production function, suppose we have y equals k alpha L1 minus alpha. You'll remember from calculus that if we're interested in what the marginal product of labor is, we take the partial derivative of this function with respect to capital, and that gives us alpha k alpha minus 1 times L1 minus alpha. And we can then rewrite that as alpha k alpha L1 minus alpha divided by k, and remember that this term is just equal to y, so we get alpha equals y over k, and that's the marginal product of capital. Likewise, we can write the y equals k alpha plus, L1 minus alpha, and we want to find the partial derivative of y with respect to L. That's equal to 1 minus alpha times k alpha L minus alpha. If you remember your how to take derivatives with an exponent, and that's equal to 1 minus alpha k alpha, and now let's multiply and divide by L to the 1, so we have L to the 1 minus alpha divided by L to the 1. So now we're back exactly where analogous to the capital situation. This is all equal to y, so we have the marginal product of labor equals 1 minus alpha times the output per worker. So that's basically how the marginal product of capital and marginal product of labor are derived in the Cobb Douglas production function.